Hello and welcome. My name is Sean Lacey of Lacey Maths and Stats Consultancy. In these set of short recordings are a demonstration of a sample of data manipulation techniques that I would often use when starting work on a data frame in RStudio. These 10 points are not exhaustive of data manipulation techniques in general and are not presented in any particular order. They are simply based on techniques that I often use prior to analyzing my data. In the first case, indexing. Indexing wouldn't really be seen as data manipulation, but its use is of help when it comes to actually referencing parts of a data frame for the functions later on. Appending a new measurement to a pre-existing data frame is something that I'd often use. I would use the mutate function for this. Now, like most statistical packages, there is more than one way of doing any particular task. I find mutate quite useful for this second point. Others might prefer cbind, and that's absolutely fine also. Sorting, reordering a data frame. It's nice that when you sort or you're reordering your data frame that you have a track record of doing that. The order function can be useful in this regard. I would often get a data frame at the very start where some of the variable names are quite long-winded, and I might want to shorten them. What I find useful in this case would be using the set names function. The fifth point here would be where we're looking at data types, trying to define the properties of our data. Again, similar to indexing, this by itself wouldn't be data manipulation, but by checking the properties of the data, this can lead to actually issues where you need to apply data manipulation techniques then to address. The sixth point that we're going to look at in this set of recordings would be where we're looking to group a measurement. So we could have a measurement like a list of numbers that we might want to actually put into categories, put a bit of structure to. I would find the if-else function quite useful in this case. There's no doubt that when it comes to data screening, looking for missing values and outliers are an integral part. There's numerous approaches to doing this, and I would hopefully just demonstrate a small bit of script that might start you off in the right direction. Filtering, subsetting your data is a lovely attribute within RStudio. I'm a big fan of the dplyr package, and I will use some functions just to give examples of how we might want to filter our dataset. Finally, converting your data from long to wide format or vice versa. It's not uncommon that when you're given a dataset at the very start that it would be in a long format, and this is the example that we'll actually have as well in a few minutes. But when you want to apply certain functions, like you want to draw graphs maybe using ggplot, or you might want to do a repeated measures using the EZ ANOVA function, you'll find that you need your data to be in a long format. Now, this is definitely something that I would have had issues with at the start with using RStudio. I was so used to having data in a wide format using packages like SPSS, Minitab, or Excel, that having to manipulate the data, reorder it, was definitely something I struggled with. And ultimately, I think it just kind of highlighted that I was at the very start, I just wasn't comfortable, I wasn't confident with doing data manipulation. I would feel when you're working with RStudio, you're always learning. And hopefully you'll find that these set of recordings will just speed up that learning process for you. I suppose the next thing would be maybe just look at some data and get into working on these points. Now, like always, if you subscribe to this channel, you'll see that any of the files that we're going to be using in the recordings will be available to download. Now, when you just look at this data set here, now this is just randomly assigned measurements across, randomly assigned, I suppose, data across 12 measurements. So what we have here is where we're looking at 16 participants on in a particular diet study, where their age was measured, their gender, their triglyceride levels at the start as a study, and then after each month. Okay, so this study was over the course of 4 months, so the triglyceride levels over the course of 4 months. Now the triglyceride levels in this case here are measured by milligrams per deciliter. Then we're looking at weight, the weight of subjects at the start, so at baseline, and then the weight of subjects over the course of the 4 months. Now, the purpose of this recording is not to do any descriptive statistics. It's not to be doing any statistical inference. The purpose of this recording is to look at the data manipulation techniques that you might have to apply to actually do your descriptive statistics at a later stage, or to do your statistical inference at a later stage. Now, I like when doing, I suppose, when you trying to get my head around data manipulation, or maybe when trying to illustrate it to people at the start, is to use a small data frame so we can quite clearly see the issues with it. And in this case, for the recording, I'm just highlighting the cells in yellow. I would feel that it's just to kind of see, look, what the problems are, to create script that will address these problems, but to create the script in such a way that when your data frame is larger, that the script can still work. Okay, so if we just look at these certain measurements here, so the first thing maybe to actually highlight here, and this probably just links in with the 10th point on the slide, the previous slide, was where the data is in a wide format. So a wide format is traditionally where you actually have information about a unit or a participant or a subject or whatever the case of the study is. And so in this case here we have participants. So we have the information about a participant all in one row. Okay, so we, in this case here, for our first participant who's age 45, is a male, we have this guy's 5 triglyceride levels, his 5 weight measurements, and then we move on to the second row, and the second row then is our next male, and so on like that. So all the information we have about a participant in the study is in a row. Now you'll find to maybe draw some nice graphs at a later stage, not so much now for these recordings, but at a later stage to draw a nice graph of the triglyceride levels over time. You would need actually the triglyceride measurements to be in a long format. You would find that if you're trying to see, is there a difference in triglyceride levels over time with respect to gender or with respect to, while controlling for age, where you're looking at doing a repeated measures ANOVA or a repeated measures ANCOVA, you might apply the EZ ANOVA function. And to apply the EZ ANOVA function, again, you need your data to be in a long format. And definitely, when I started off with RStudio, this was something I didn't like. I didn't like that I couldn't just go off and do the test. Like, I was very familiar with doing work in SPSS or at Minitab, and it was kind of, once you had your data in the wide format, you were good to go. With OR, you have to manipulate your data. And I think ultimately when I kind of became comfortable and confident with doing the data manipulation and basically doing the analysis, then was actually okay after that. Okay, so I think a big importance is placed on being comfortable with doing the data manipulation. So issues that we have for this one, so the first one here, for the first measurement, we're looking at measuring people's age. We can see here for our 16th participant that the age is entered incorrectly, it's not entered as a number, it's entered as a string. So when we look at, I suppose, checking the data type for this measurement, we're going to find that this guy here will cause us an issue. The second column here is relating to the gender of participants. Now, you can just see at the top here when it comes to the title of the measurement, gender of participants, I would think that that's kind of long-winded. There may be something a small bit more concise, where you call something gender would be a bit better. But if we change it here in Excel, there's no track record of changing that. Okay, I would always feel that if somebody gives you a data set in Excel, you shouldn't manipulate it in Excel. When you want to manipulate it, you should have a track record of all that manipulation. So basically, you should be doing that in RStudio. So even though it's quite simple to do it here, I think it's much better where you actually have the track record of doing that. So we're going to do it in RStudio. And that's where we're going to use the set names function. And we're going to do the same thing down here for the final triglycerides TG4. The only reason I wanted to do 2 is just to show you the line of code that we can use that can address more than, I suppose, changing more than one variable name at one time. When we look at the data types for the gender of participants, in this case here, we'd expect it to be binary, as in it's either male or female. You can see here with one of the measurements, the responses here is M. So this is what RStudio will pick this up as is actually being tertiary, and we don't want that, so we need to change this M. Obviously, we want it to be male, but again, how do we actually address that? The other one then will be the triglyceride measurements of our 16, I suppose, of our 16 participants after 1 month. So that's what the D column here relates to. And we can see down here that we have an outlier. Okay, so when it comes to the triglyceride levels, and again, they're measured in milligrams per deciliter, on average, your average value would be roughly around 150, no, left and right of that. Okay, so we can clearly see that 1030 is clearly an outlier. So how do we address that outlier? Now, the thing is, it's how do you find the outlier first? So the first thing is to be able to find it. Now, here we can clearly see it's right there. The data set is small. But if we have a larger data set, how do we actually find it? Okay, so how do we find the outlier? Then how do we change it if it's a typo, which in this case it would be a typo. Then over here for the triglyceride measurement after 2 months, you can again see here that there's an issue. We've missing data. So how do we find the missing data? But then it's more a case of how do we find the participant that has the missing data? It's to track down the participant with the missing data and then either to ignore that participant or to impute a data value. So if you're ignoring the participant, you're kind of doing this thing called a per protocol analysis, or if you're imputing a value for the participant, then you're doing this thing called an intention to treat analysis. So again, it's not, the purpose of this recording is not to kind of get into that overall idea of the different types of analyses out there. The purpose of this recording is basically how do you track down the missing value, and how, in this case, how do you impute it, okay? Then the weight measurement, you can see that you have a missing value over here. Now, I'm not overly going to be interested in the weight measurements. I purposely put these in is in more, this will come down to the filtering step later on, that I just want to kind of filter the data set down to something that's a bit more manageable. So I'm going to want to get rid of the weight measurements, and it's just more of a, I suppose, to show you the scripts that we can actually use to get rid of a measurement. Okay, in this case, to get rid of these 5 measurements, as in they're not going to be the point, I suppose, measurements of interest. Okay, so if we go to RStudio, we can see in RStudio, so what I've done here is I've already imported the dataset. So I've imported the dataset, which is going to, it's an Excel file called Diet Study. If you subscribe to the channel, you'll be able to actually download it yourself, and then you can import it into your own RStudio and kind of be repeating these steps if you want. You can see here I've imported it and I've it set up here. Okay, so this is basically the same data frame that we actually have in Excel. Okay, now, as you're more likely very familiar with, when you're using RStudio, part and parcel of using RStudio is where you're installing packages and then calling the libraries. What I find useful, especially when I kind of got, I suppose, more comfortable with using RStudio, is I kind of kept a list of all the packages that I require for a certain project. So for this kind of, if we call it, this is the project, which is basically a set of recordings. The packages that are required here are these 5 packages. So to read Excel, which is the one to just import the data at the very start. Then you have your data.table. This will be for the set names function. ggplot will be for actually doing a plot. This will be where we're going to be trying to find the outliers. dplyr is for we're going to be looking at filtering at a later stage, and also the mutate function. And then tidyr is going to be used when we're looking to confirm, I suppose, to change our data from a wide format to a long format. So I find it useful to actually, I suppose, keep a list of the packages that I require for a particular project. So that would be these 5 here. So this is in a notepad. So again, I'll upload this to the YouTube channel so you can download it then if you subscribe. So these will be readily available to you. So I'm going to come here to R, and then just going to paste them in. Okay, so this is just, now most of these will be probably already installed for me. This is where I can just, or is just checking, are the packages installed? If they're installed, fine, that's grand. Check is the library loaded, and that's all. Okay, so I'm just going to highlight them, press Control R, sorry, not Control R, press Control Enter, and you can actually see here it's actually installed some of the packages and load the libraries. Okay, so you can just see that everything is fine now, everything is in order. Okay, so the first thing I just want to just look at for this recording here is just to work through a few different scenarios when it comes to indexing. Okay, definitely, when at the start, when I wouldn't have been comfortable with indexing, so I think it's just a good point to start off with. Now, for this, I'll upload the script that I'm going to use here, so I'm not going to put in too many comments for this for the purposes of the recording, but I will upload the script to the YouTube channel afterwards, and again, if you subscribe, you'll be able to download this with all the comments, okay? So, the first thing I'm going to just look at is just doing a small bit of indexing. So indexing, the thing to remember with indexing is it's always in relation to rows by columns. Okay, so the first, so it's basically where you index something by 2 dimension. Okay, so if you index, we'll say 1, 2. 1, 2 would mean your first row, your second column. So that's how we always try, I suppose, reference values or range of values within a data frame. Okay, so just to do these, I'm going to just work through 6 different examples here of different, I suppose, ways of indexing. Okay, so the first one is where I might look for a particular value. So I state the data frame being diet. I do square brackets then, so this is where I'm focusing on a part of the data frame. I'm going to just do 2, 3. So what 2, 3 relate to, and this would relate to the second participant in the study, so that's the second row, and it's going to relate to my third measurement. So if I remember correctly, the third measurement, which is our third column, is to triglyceride levels at baseline. So the value we should be getting back here, if we run this off correctly, is 139. So I'm just going to do up here, press Control Enter. If I press Control Enter, you can see down here we're getting 139 down in our console. Okay, so this is just a way of referencing a particular value. Where we'll find this useful and of a requirement is when we actually isolate a participant that has missing value or a participant that has an outlier, and we want to change the value. So that's where this is going to be of interest to us, okay, that kind of approach. The other thing is where you might like to look at a range of participants. for a particular measurement. So as an example here, what I'm going to say is I'm going to look at our fourth participant up to our seventh participant. So I'm looking at a range of those, okay, and I'm going to look at it, we'll just say for the fifth column. So what the fifth column is will be our the triglyceride levels after 2 months. Okay, so this is participant 4, participant 5, 6, and 7. For the fifth column, so the fifth column is our triglyceride levels after 2 months. So if I'll press Control or Enter there, and you can see here we're just isolating those 4 values. Okay, so it's a nice technique for this. Okay, the other one then is where you might be interested in a range of rows, as in a range of participants, and a range of measurements. Okay, so as an example, we'll just say what will we say? We'll say the first 5 participants, so 1 to 5. And what we will look at is we'll look at their triglyceride levels at this, we'll say after 1 month and after 2 months. So just as an example. Okay, so I'm looking, so 1:5 is looking at the first 5 participants, and then 4:5 is here where we're looking at this column 4 and column 5. And if we go back to our data frame here, we see column 4 is triglyceride levels after 1 month, column 5 is triglyceride levels after the second month. Okay, and if we do that here, it just outputs those. And this is a very good way, again, this is like subsetting your data set. Now, I'd often, if I'm subsetting, I would use kind of the dplyr package. I would use the filter function, and we'll see this at the 9th data point. But this, again, and this is something I mentioned that earlier on in the recording, there's more than one way of doing tasks within RStudio. Okay. The other one then, the other thing that I find sometimes quite useful is where I might just want to isolate a participant. So I might want all the information that I have for a particular participant. So we'll just say for participant 2, I want all his information. So I'm going to say the second row, and I want everything going across. I want all the columns. So if I do 2, comma, and just leave after the comma, just leave it blank, I'll just do something like that. Now, I don't need all that white space, but I'm just kind of highlighting what I'm doing here. That will just output all the information that we have then on the second participant. Similar approach then is if we wanted to look at information that we have, I suppose all the information that we have maybe on a particular measurement. Again, so say as an example, say we want the triglyceride levels at baseline. So the triglyceride levels at baseline would have been our third column in. So say we want all the information. So I'm going to just, again, that white space isn't needed. I'm just kind of highlighting it just more, as you can see that I'm leaving it blank. So you don't necessarily need to do all those white spaces. And I do a comma. The comma means now I'm moving into the column. And if I do 3 here, what I'm going to get output to here is my third column for all the participants. Sorry, I didn't mean to press enter there. So I should press Control Enter. And then it's just going to output all those measurements. The last thing, and again, to be comfortable with indexing, what I find I use on a regular basis is where I might want to exclude either a participant or I might want to exclude a measurement. So just kind of, I suppose, just because I want to move on to the second point anyway as well. So just to say if I want to exclude a measurement. So we've talked about the triglyceride levels at baseline here a few times. So just say we wanted to exclude the triglyceride levels at baseline. So we wanted to take out the data frame that we had, but just ignore a particular measurement. So ignore, we'll just say as an illustration, the triglyceride levels at baseline. So we do a white space, comma, so we're including all the participants. We remove the third measurement, so we say -3. So -3 then was going to output this data frame without the third column. If I press Control Enter here, you can see then here that if I just scroll up a fraction here, you can see you have the age, you have the gender of participants, and now we're missing TG0. Okay, so what I just find is useful is nearly to kind of get your head around this, because this will be an important part, especially when it comes to the outliers and when it comes to the missing values later on, that just maybe if you kind of maybe looked at a range of numbers and said, well, I wonder how could I index those numbers. So if you did it kind of as a bit of a trial and error, you could say, oh, what if I wanted to just isolate 172 and 214 here? What if I just wanted those 2 values? What type of indexing would I use for that? I feel that that's just a very useful thing to kind of get your head around, and it will benefit then at a later stage. Okay, so if we come back here just to the points where we're on, I just wanted to, I feel it is important to talk about indexing at the very start, even though it's not necessarily data manipulation. The other thing that I find is useful is appending a new variable. So sometimes you'd often do a calculation, you'd create a new measurement, which could be the sum of other measurements or something like that, or maybe the average of a list of numbers or something, and you want to append that on. Okay, so to append a new measurement, I would use the mutate function, which is part of the dplyr package. Now, to maybe just illustrate illustrate that, what I'm going to just say here with the data frame that we actually have, if I go to my RStudio here, what I feel is missing here, and something that we should always be careful to actually have in our data set or a data frame, would be a subject ID or a participant ID. Okay, so we can see here that we have 16 participants, but at no point do we have any kind of track record for them. So if we reordered our data, which is something that we're going to look at in our third point, it's always useful to have a measurement that will bring it back into its original order. And we don't actually have any measurement here that can allow us to bring back the data into its original order. I would feel a measurement that is very useful to have in a data frame would be a participant ID or a subject ID or a unit ID. It all depends on what your study actually is, okay? So I'm just going to look at, first, I suppose, the idea of maybe just creating a subject ID measurement, and then how do we append it, okay? So what I'm going to say here is we'll say add participant ID. So something like this, okay? So, and again, I'll put in more additional comments in the script that I'll upload to YouTube later on. Okay, so the thing is here, we want to create a participant ID. Now, so what I'm going to do is I'm going to create a participant ID, give it a letter. So participant 1 is going to be letter A, participant 2 is letter B, and so on like that. Okay, so we have 16 participants, so obviously we can nearly count how far up in the alphabet we want to go. But I think it's nearly to create code, to create a script that would do it in general. Okay, so what I feel is useful is we need to figure out, look, we know that there's 16 participants. How do we get OR to tell us that there's 16 participants? More than one way of doing this. I feel one approach that I often use would be using the dimension function. So if I use the dimension of my data frame, so dimension of diet, so if I use dimension of diet, it's going to come back with here that it tells me, as we can see over here even, that we have 16 participants across 12 measurements. So we should come back with a 1612 if we run this, and that's what we come back with here, down 16 and 12. Now the 16 relates to our sample size, relates to the number of participants. If we wanted to isolate that value, what we could do after the dimension diet, in square brackets, we could just state 1. Okay, so if we just do something like this, this will just output the 16, okay? Now, when it comes to that 16, I want to assign that to a particular variable, so I'm going to call that n, okay? So I'm going to say n, basically, the dimension of my diet data frame, the number of rows I have, which is 16, I'm going to assign it to n, okay? So I'm just going to run that off. And then now what I'm going to do is I'm going to create a participant ID, and I'll just call it ID, okay? I'll call it ID. And what I'm going to do here is I'm going to say the letters. So it's going to tell RStudio to use letters. Now, the fact that I did letters in uppercase means it's going to output uppercase letters. I could do letters in lowercase, and then that will mean it would output lowercase letters. So that's what we have. And I'm going to say letters of 1 up to n. Okay, so again, this is where I'm making it more general. Okay, so we know it's 16. I don't want to state 16 here because the next time I do this, I might actually have 16. So the whole thing with RStudio is to create script that you can use that will make life easier to maybe at a later stage, or create script that's more general. Okay, so I'm going to use n like this. I'm going to just output the script this as well. Okay, so if I look at letters 1 to n and I'm assigning it to ID, it's just going to store it there. But I want it to store it, and I want it to output it. So I'm just going to do brackets around it like that, and I'm going to press Control Enter, and you can see here now it's giving me the first 16 letters of an alphabet. Now, this ID measurement that we actually have, that is not associated with our diet data frame yet. Okay, so we need to append it to the diet data frame. It's out there in limbo by itself at the moment. So to append it to the data frame, I'm going to use the dplyr package. So just to make sure, as a sanity check, that the dplyr library is loaded, I'm going to call in library dplyr. It is, that's loaded, so I didn't need to do that. I find it's useful to do that because at a later stage when I come back to this script, I might forget that I needed the dplyr package, and I might need to reinstall it for some reason. Maybe I had to reboot or something like that, okay? So I find it's just sometimes useful to state the library that I'm using even throughout the script as well, even though technically we didn't need it because it was stated up here. But it's kind of what I like to do as well, okay? And what I'm going to do here is I'm going to take the diet data frame. I'm not going to create a new one. I just want to basically take the measurement that I have and add it on. So basically here at the diet, I want a new column at the very end, which will be A up to P. Okay, so going to use the mutate function here. So mutate. You take the original data frame, which the original data frame is called diet, and you're going to mutate on the ID. Okay, so we do something like that. I press Control Enter. That's seems to run. There's no red script down here, so that seems to be quite good. Come up to the diet up here. I'll come up to the data frame just to see it here, and you can see, look, there we have the ID measurement. Okay, so we have that ID measurement, which is A down to P. And what this gives us now is just a nice kind of reference, point of reference, that if we happen to mix up our data, which is something that we can be doing when we're looking at the third point for these set of recordings, which is where we're looking at sorting or ranking our data frame. This allows us having some way of bringing it back to its original form, and that's something that is quite useful. Okay. Now, the one thing that I wouldn't necessarily like with this, and this is just purely down to formatting, nothing to do with any kind of descriptive statistics later on or anything like that, is I would feel if we're going to have a subject ID or a participant ID, we should have it at the very start. I would just think that it looks better at our data frame that our ID measurement will be at the very start, and that's what we're going to be looking at when it comes to the third point here. Okay, so sorting is just where we're going to be might want to sort our data frame based on the triglyceride levels that's the baseline or the weight of the baseline. If we wanted to do something like that, we're going to use the ordering function for that. The reorder the data frame is where we might want to swap around the order of the measurements. Maybe in the example we're going to use will be where we're going to look at the ID measurement and put that at the very start. Okay, but what I'm going to do here is I'm just going to stop this recording. So we'll put this down as part 1, and then I'm going to come back in part 2 and we'll address a couple more of the points. Okay, so if you come back to me, we'll continue on with these next few points.